Hello and welcome to another exciting episode of Mark Fixes Stuff. In the previous episode this arrived, this monstrosity, in a carrier bag. However, we've ordered some parts and here they are. And with these parts we're going to repair the electronics on these boards. We've also got some metal polish so we can deal with this mucky shielding, and we've got some plastic polish so we can try and deal with the external appearance of the machine. The first board we're going to concentrate on is the main board. This has capacitor leakage, so it's quite important to remove these capacitors and neutralise the alkaline leakage before they do any further corrosive damage to the board. I think we might have got away with this one, but you can never tell. Next, we're going to replace the save game battery, the one that was physically ripped off the board, and I can see why. They've attempted to remove it, but this ground plane has probably thwarted their underpowered soldering iron. To limit any potential thermal stress on the solder pads, I'll be cutting the SMD capacitors gently from the board. I find this technique quite safe, but you will need sharp side cutters. Once the top half of the component has been removed, it's really easy to remove the lower half. We simply lift it free from the remaining legs, making it much easier to remove the stumps of the component. With all of the SMD capacitors removed from the board, we're ready to do some reworking. Whilst working on the board, this little sticker's come loose from the EEPROM. It's exposing the quartz glass window, which could be used with ultraviolet light to erase the contents, but we're not going to have that. We're going to use some glue, and with just a dab of glue and careful replacement of the sticker, we're back to showroom condition. There are also a couple of leaded electrolytic capacitors on the board which need replacing. I cut through the legs on these because I find it makes it easier to remove the stumps with less heat needed. Whilst we're taking out the trash, let's remove the remnants of the battery that someone else left behind. Using a very weak vinegar solution, we neutralise the alkaline that's been left behind by the leaked electrolytic capacitor. This will help stabilise the board. We can now see the damage left behind on the solder on the pads. This old and damaged solder can be difficult to remove, so I add some fresh solder and this often helps. Even the application of fresh solder doesn't help remove the muck from the pads though. We're going to use some rework solder flux. Unfortunately, it can be a bit unwieldy out of the can, but don't worry, we can wash that off with some IPA later. After that generous dousing of flux, we're ready to use some solder wick. Using a hot iron and constantly moving the solder wick, we can clean the solder pads to a much better standard. A quick wash down with some isopropyl alcohol, and then a clean off with the cloth to buff up those pads. There, these will be much easier to solder onto now. Time to clear the holes left by the old battery. Let's just heat this up. And with the solder removed, it's just a matter of removing the loose leg out of the hole. We're now ready to put the new battery in. There is a slight problem though. I've bought the wrong battery format. It is rechargeable, but it's the wrong shape. I think we'll just have to make it fit. It shouldn't be too difficult though. Well, those line up, so if we bend this tab back, a small amount of gentle persuasion, it's roughly the right position, that goes in there. By bending these down, we should be able to make it fit. Almost perfect. Of course, this is my machine and I wouldn't do this on anybody else's. A quick blob of solder to hold the battery in place allows me the use of both my hands to properly solder the other terminals. I have to work quickly because these boards are very sensitive to heat. Then I simply revisit the original blob of solder to make sure it's a good connection. Testing the battery only shows 2.4 volts instead of 3 volts, but remember this is a rechargeable battery that has been in storage. Next I replace the through-hole capacitors with Panasonic parts. The ground plane on this board is massive and can prove difficult to solder. Even using my temperature controlled soldering iron, sometimes it's a battle between lifting the pads and melting the solder. Next we'll reattach this resistor so it's back to the way it was when it left the factory. Once again we're soldering onto that massive ground plane, so it can be difficult to keep the solder molten enough. I think that will just about do. Finally we'll snip off the component leads to make this nice and tidy. Next are the surface mount capacitors. These are all Panasonic. To mount the SMD capacitors, I'm using a blob of solder on the pad and a blob of solder on the SMD capacitor's lead. Then I'm simply joining them together with a fine-tipped soldering iron. Flipping the board around and applying some pressure to the top of the capacitor, I join the other side. With the SMD capacitors all installed and checked with a meter, it's time for the final through-hole capacitor to be installed. I'm doing this last because it was in the way of the other components. Again, that ground plane can be a bit problematic, and we'll cut those leads off. So, that board's done. It might not be my most attractive rework, but it's certainly better than the leaky mess that it was when it arrived. Time for the subboard. First we'll remove this ribbon cable so it's not in the way anymore. Now we need to remove the stumps where someone did an aborted fuse replacement attempt. Again, the solder really doesn't want to move, so I think we'll add some fresh solder. That usually helps to get things flowing. If you saw the previous video, you'll know that the fuse was completely missing when this unit arrived, and we've checked out TR4 with a diode check function on a multimeter, so we know that works. I'm finding soldering on this board quite difficult. The solder doesn't really want to clear out of the holes. The board also seems really sensitive to heat, so I'm going to take it slow. Using some isopropyl alcohol, we're going to clean both sides of the board, and then we'll be ready to install the new fuse. These are 2.5 amp Pico fuses. Normally the fuses are found mounted in an upright position, but I think with this one what we'll do is we'll mount it flat to the board. I don't know why, it just seems more elegant. I'm just bending the legs now so that the fuse doesn't drop out when I flip the board over in order to solder it. Soldering as quickly as I can to avoid lifting the pads, and snipping the component leads, our new fuse is in place. The subboard of the MegaCD handles power and some audio functions. The capacitors can also go bad, so I've removed them all. This was not an easy task however, and there are some lifted pads which I'll need to repair. You can see a good example here. It simply flaked off the board at the merest touch of the soldering iron. Once I've installed the new capacitors, I'll check for continuity with a meter and make repairs as required. Installing capacitors is not the most fascinating thing to watch, so I've sped this up for you. As I'm working, I'm looking to see if any traces have lifted and looking to see if there's anything I'm going to need to repair a little bit later. I can see a couple of things which I can just bridge with solder. Snipping off the component leads, I think that I've probably made all the repairs I need to, so I'm going to check with the meter. Everything seems fine up till now. But then disaster strikes. There's a break in the track here, so I'm scraping the top layer of the circuit board off to expose the copper underneath. Once I've exposed the copper, I'm cleaning the area of IPA, and now a small blob of solder will easily bridge this gap, fixing the problem by restoring the circuit. Checking the repair we just made with the meter shows continuity. Phew. Being a bit paranoid, I also checked the repair from some other points. They all check out as well, so I think we've done the trick. Okay, so we've reworked both the boards. The first board wasn't too bad, but the second board, oh boy, that was a bit of a trial. The pads just lifted at the merest suggestion of heat. I'm almost scared to test it now, but test it we must, so without further ado, let's put it back together. And by put it back together, I mean put it back together just enough so that we can test it. Obviously this will all still need to be cleaned. I don't want to go ahead and clean everything without testing that the unit's working. It might be a waste of time. It might break my spirit. Lastly, popping a Mega Drive on top shows that it's a bit wobbly without the case to support it, so I'm going to use this pair of pliers to hold it level. You can see that it's just level enough so that it stays in line with the connector. The right tool for the right job at the right time. For legal reasons, I feel compelled to say, don't try this at home, kids. Both the MegaCD and the Mega Drive need their own power supplies. The specification of the power supplies is 9 volts with the centre tip negative. They need to be able to supply 1.2 amps or 1200 milliamps. Both of mine here will supply 1.5 amps. Next we'll need a controller. I can't find my favourite controller, I can only find this old Konix one that isn't very good, but it'll be fine for working the menus if the whole thing powers on. The plug on this Konix controller has always been really difficult to insert, like it's slightly too large, but it's in and it'll do. And finally we need to see if we've got any output on the screen, so we're going to use this RGB SCART cable. I got this one from Retro Computer Shack. And it's highly recommended. Okay, so now we're going to go live. It's live testing time and I'm experiencing this at the same time as you. So this might be a bit interesting. So everything's powered up. There is power to the MegaCD. There's power to the Mega Drive on the top. Everything's connected together. We're connected up to the TV. The sound's connected in. I've stuck it about halfway up. I've plugged this terrible Konix pad in just in case it works. So here we go. I think we're on the right TV station. Yep, TV station. Show my age there, YouTube. Here we go. 3, 2, 1. I can't even look. Oh, look at that. Well, that is playing. Doesn't seem to be any video corruption, so press reset to open the CD tray. Reset. Oh, that's on the console, isn't it? Leave it open because I didn't change the drive band. Doesn't look like it's going to open. Oh no, it's opening. That could probably do with a clean, that band, but that's part of the cosmetic process. It will come next if we can get it to play anything. And we didn't recap the CD drive, so we'll have to see what happens with regards to that. Yeah, we're going to press start. Actually, the motion on that drive is not too bad for push-pull. And this is, not that it's loading, but this is Road Avenger with one of the worst pieces of music in the whole... Oh, hang on. Hey! That is very, very promising. Wolf Team. Excuse me. Wolf Team. Oh, that seems to be running fine so far. Let's see if it's choppy because it plays the audio off the CD here. So we went from a dead unit to one that is playing discs. Yay! Covered in slime and junk and all sorts of stuff. On the road. Sounds like a record that's been slowed down. Anyway, in the next exciting episode, I'm going to just clean this up, put it back together, try to make it cosmetically acceptable, and play a couple of games. Maybe see if it plays CD copies. Cool. Well, subscribe to get your fix. If you like this video, tell others. If you didn't like this video, keep it to yourself. But if you did like this video, perhaps you'd like to look at some of these other videos. Here, I'll put them on the screen for you. Bye.